Okay, shall we start? No. So this is another applications of definite integral, and this time we'll be talking of volume of solid of revolutions. And you know that the volume of a cylinder is equal to pi area of the base, which is pi r squared times the height. That the volume of the cone is equal to 1/3 of the area of the base times the height, and that the volume of a sphere is equal to 4/3 pi r cubed. And for today, yeah, we'll be talking of some concepts of solid of revolution and how to find its volume. Okay, so let us consider a rectangular region. Say in this case, it's a rectangle. Yeah. And to be revolved over this line, the axis of revolution is any line on the plane. And you will observe that when this is revolved over this line, just take a look what will happen. And then we can generate a right circular cylinder. And then when the region is a triangle to be revolved over this line, so again, this will be revolved over the axis of revolution. So you will generate a cone. And then if this region is a semicircle, then you will generate a sphere. So this cylinder, the cone and the sphere, they are called solid of revolution. And we define the solid of revolution to be a solid obtained when the region bounded by different curves is revolved about a certain axis of revolution. So a solid of revolution is a solid obtained by revolving a region in a plane about a line on the same plane. We call it the axis of revolution. And there are three ways on how to solve for the volume of solid of revolution. The first one is by this method, or the cylindrical disc. Another one is the circular ring or the washer method. And the third one is the cylindrical shell. So in this presentation, I will teach you how to choose the appropriate method to use to solve problems on volume of solid of revolution. And let's start with the cylindrical disc. No? So we know that the area of a cylinder is area of the base. That's area of the base times the height. And you know that the base of a cylinder is a circle. Yeah. So that's why this is pi r square h. So let us consider a region bounded by y equals f of x. This line, line L, and between two vertical lines, x equals a, x equals b. And here happen to be that this line, one of the boundaries, is our axis of revolution. Okay, so that is to be revolved over here. So when this is revolved over L, so you'll have an image here. And just copy it out here, and then you'll have this. So this is the solid form when this region is revolved over this axis of revolution. Okay, and it will look like this. So you choose an element. Say we use an element that is rectangle. That is vertical. So in this case, we are taking element that is perpendicular to the axis of revolution, and that is one condition to use the cylindrical disc. Okay, the first condition is that the axis of revolution and the element are perpendicular. So here we notice that the axis of revolution is a horizontal line, and therefore we take an element that is vertical. Okay, and you can also see that the element chosen is touching the axis of revolution. Why is that happening? It's because the axis of revolution is one of the boundaries. Okay, one of the boundaries of this region is the axis of revolution, the line L, and with that, the rectangular element drawn will be touching the axis of revolution, and that's another condition when to use the cylindrical disc method. The rectangular element is touching the axis of revolution, or the rectangular element is part of the region. So this, the whole solid here, something like it's really a solid form, solid in form. There's no empty space here. Okay, an illustration of which is this. Okay, yeah, and this is what will happen. Can you see this one? Yeah. It's solid, no? So, and you have to take note that the axis of revolution is part of the region. Okay. And this is the axis of revolution. And then the line x equals A, x equals B are the two boundaries. Okay, so that is the first illustration. And with this, you'll be using the cylindrical disk method when you are taking element that is perpendicular to the axis of revolution and that the element is part or the element is touching the axis of revolution and the axis of revolution is part of the region. And how do we find the volume? Okay, so the idea is to divide this this solid by series of cylinders. Our particular example dyan is yung hot dog, no? Say this is hot dog. And then the stick. And when you cut it out here, so you will form series of cylinders of this form. Like yung Mentos na candy na nasa tube. Okay, that's it. Each piece of a candy, yung Mentos, you know that yung Mentos na candy na nasa tube like this, yung nasa tube na ganun. Na pag kumukuha tayo, yung pinipitik lang natin na ganun. Yeah, that's the idea of cylindrical disk method. And each piece of the Mentos candy is a shape of a disc. No, it's really a disc. So just like this. So the idea is to divide this by series of cylinders. Okay, yun. And we know that the volume is equal to the volume of the first cylinder plus the volume of the second cylinder plus running until the volume of the nth cylinder. Okay, so that's V1 plus V2 running until V sub n. And then again, we get a representative cylinder and this one. So this is your, when this element chosen, this element is revolved over the axis of revolution, and this is what will happen. This is the axis of revolution. So you'll have an image like this. Oh, you'll draw an image here. Okay, so you'll have this. Okay, and that is what will happen. Yeah. Okay. When this rectangular element is revolved over this line. So we take one representative cylinder and this one. So this is your R. And this one is your xi minus 1. And this one is your xi. So you have xi minus xi minus 1. And that's the length, the height. Yeah, the height. The height, why is it L? The height of the cylinder, and that is your delta x. Okay, so that's why this is delta x. And R is this much, that's the radius of the cylinder. Okay, so you have V equals V1 running until V sub n, and you know that the volume of a cylinder is equal to area of the base, it's right here, area of the base times the height. So you have a sub 1 of x, delta sub 1 of x, where height is delta sub 1 of x, plus a sub 2 of x, delta sub 2 of x, running until a sub n of x, delta sub n of x. And you know that the area of the base is pi r square. So you have pi r sub 1 squared, delta sub 1 of x, running until pi r sub n squared, delta sub n of x. And this Riemann sums can be written in summation notation of this form. Okay, so that's summation of pi r sub I squared delta sub I of x, where I runs from 1 to n. Can you still hear me?
Yes po, sir.
Okay, thank you.
Yes po, sir.
Okay, and then again, to eliminate the error, to get the best approximate volume of this solid, so we will be using infinitely many number of cylinders, and if that happens, then the height of each cylinder gets thinner and thinner, and the height delta x will approach 0 as the number of cylinder approaches a very large number. And in this case, you can now take the limit of this function. So that's the limit of the summation of pi r I squared delta I of x, where I runs from 1 to n as delta x approaches 0. And this can now be written in integral notation. The volume is equal to pi integral of r squared dx evaluated from a to b. And on this particular illustration, your r can be written as y upper minus y lower. That's why I keep on reminding you when I discuss the area of region bounded by different curves to always remember the upper and lower thing, the y upper, y lower, and the x right, x left thing, because that will be used when we reach this particular lesson. Okay, so, and this is what will happen whenever the axis of revolution is the x-axis. No, because when this is the x-axis, so this is a function y equals f of x. So when you draw your r, it's y upper, that's the function f of x, minus y lower, that's the x-axis, and that is the line 0. So you have f of x minus 0, and therefore that will become f of x squared dx when the axis of revolution is the x-axis. Okay, and this is the theorem. If we let the function f be continuous on the closed interval ab, and we assume that f of x greater than or equal to 0 for all x in the closed interval ab, and if s is the solid of revolution obtained by revolving the x-axis region bounded by the curve f of x, the x-axis, and the lines x equals a and x equals b, then the volume v in cubic units is given by this. You have to take note that this is the axis of revolution, and it happened to be that's one of the boundaries. So that's why the element will touch the axis of revolution, because again, the axis of revolution, x-axis, is one of the boundaries. Okay, and then now, what will happen if the axis of revolution is no longer the x-axis? In this case, that's y equals x naught, or y equals x sub 0. Okay, so let us consider this one. If this is no longer the x-axis, so by following the y upper, y lower, so this is your r, okay? So to easily identify the value of r, no, the expression for r, you just trace it out. You just trace your element. You draw the element, and then if it is vertical, you trace it from the top to bottom. Okay? And then you look at saan ba sila tumatama. So in this case, this is touching this curve. So that's your y upper, f of x, minus, and then you go down, it is touching this line, and the equation of which is x naught. So that's x sub 0. Okay, so that is your r. Oops. And then the volume is equal to pi integral of f of x minus x sub 0 square dx evaluated from a to b. Okay. Next, if it is located above the region, ito yon. So what will be your r? Can I hear someone?
X naught minus f of x.
Minus f of x. So that's still y upper minus y lower. Your upper part is the x0, and then your lower part is the f of x, and this is the volume. X naught minus f of x squared dx. Okay, then next, another modification of the formula is that when we take element that is horizontal, and the axis of revolution vertical, they are perpendicular to each other. Or the other way around, pwedeng on the other side. Okay, and if the boundaries are the function g of y, the y-axis, and the lines y equals c and y equals d, okay? So in this case, it will look like this. That's the y-axis. This is the function y or x equals g of y. Hold on. And then the two, all right? So this is the line y equals c, y equals d, and this is the region we are referring to. So you draw an element perpendicular to the axis of revolution. Okay, this is the axis of revolution. So meaning that is the x right, x left, and the x right is the function g of y, and then the x left is the line x equals 0. So that's r equals x right, that's g of y minus, this is the right thing, and then you go to the left, this is the left side, and that is 0. So that's why this is integral of g of y squared dy evaluated from c to d multiply with pi. And then next, if the axis of revolution is no longer the y-axis, this time we're setting x equals y naught to be any constant. And if it is located on the right side, so how do you write your r?
Y naught minus G of Y.
Minus g of y. So the volume is this. And then when it is located on the left side, okay, how do you write your r?
G of Y minus Y naught.
Y naught. Okay, and then that's the volume. Okay, you remember all those formulas because that shall be used whenever we solve problems involving solid of revolution. This is the first formula, and then we will solve the same problem by applying another techniques. Okay, problem number 1. You ready? And here are the steps pala. So in finding the area of solid of in finding the area of rectangular region, I enumerated 6 steps. Ito nadagdagan lang ng isa. Obviously, you have to trace the curves, and that's the first thing that I have to look for on your solution. So the curve, and then you identify the region described on the problem. Okay, and then again, wrong region, no credit on the examination. Wrong curve, no credit on the examination as well. And then you choose the element, either vertical, horizontal, rectangular elements, and you will still apply the three ways on how to identify the appropriate element. Okay, number 1, the number of slices, right? You divide it horizontally, how many slices? You divide it vertically, how many slices? And then you choose the method wherein you can divide it into the least number of subdivision. And then if they are of equal slices, then the structure of the equation is the next test. Okay, and then you look for y in terms of x, x in terms of y, identify whichever of the two is easier to integrate, then you choose that method. Okay, and then number 3 is the points of intersection. Okay, and then on this part, we are taking element perpendicular to the axis of revolution because this is the first method that I have introduced to you, this method, and you are taking element that is perpendicular. But after discussing the 3 methods, you have the free will on what method you're going to use. It's up to you. You just choose the most appropriate. Number 4, you find the boundaries, and again, these were usually taken from the point of intersection. And then number 5, you revolve the region over the axis of revolution. Number 6, you set up the equation, and then number 7, you integrate to find the volume. You take a screenshot of this step. 1, 2, 3, 4, 5. Next. Sample number 1. Find the volume of the solid generated when the region bounded by x minus y plus 1 equals 0, y equals 0, x equals 0, and x equals 1 is revolved about the x-axis. The axis of revolution is the x-axis, and that's one of the boundaries. This line, y equals 0, is the equation of the x-axis, and that's one of the boundaries. That's why the element to be chosen would be touching the axis of revolution. Okay, because the axis of revolution is one of the boundaries. So we trace the curve. Okay, you know now what to do. You just replace, you just use this point, substitute it to the given equation, and then you look for its corresponding value of the variable. Say if y equals 0, if this is 0, you can see that x is negative 1. So you have negative 1, 0. The next, if x equals 0, if this is 0, then y is 1. See that? Okay. But when x is 1, this is 1. So y will be 2. So you have 1, 2. And these are the points. The y-axis, that's the line x equals 0. The x-axis, that's the line y equals 0. The point 0, 0, the origin, negative 1, 0, 0, 1, and 1, 2. And then you trace the line. This is the line y equals x plus 1. And then what else? We have x equals 1. Okay, and you have x equals 0. So the region we are referring to is this much. Okay, so this is the region that is bounded by this line, this line, this line, and this line. So it will look like this. Oops, sorry. Okay, and then you identify the element. You try to divide it horizontally. How many slices? How many subdivision? When you do it horizontally?
1 lang po.
Horizontal. Check it again.
Dalawa po.
Dalawa. Okay, yeah, dalawa. Ito yun, oh. So, horizontal, boundaries here until here. But when you reach this point, nagbago na yung kanyang boundaries. But when you do it vertically, oh man, how many slices?
1 lang po, sir.
1 lang po. So, ibig sabihin, the most appropriate technique here is vertical. Okay, and this is the axis of revolution. So, this is the axis of revolution. When you divide, when you revolve this region over this line, it will look like this. And then you just put something like this to make it a little, 3D. Yeah, that's the solid we are looking for. So you take element that is vertical, and this is the region or the solid we are looking for. Yeah, so hindi nakasama to ha. Hindi na to, ito lang dalawang to. So iyan ay buo, no? Walang hindi empty yung gitna, yeah, because the element is touching the axis of revolution. Okay, and then so you have R, this is your R, and that's happened to be x plus 1, right? Minus the x-axis 0. So that's your R. And then this is dx. Okay, I'll just show you how. I'll not discuss this anymore. All right. I only use the change of variable, a power formula, and you'll see that the volume is 7/3 pi or 7 pi over 3 cubic units. Okay, you take a screenshot of that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, next. Let's modify this problem. So this time, we will make use of line equals y equals 2. Sorry, line y equals 2. So the same curve, x minus y plus 1, but this time, one of the boundaries now is y equals 2, and x equals 0, and x equals 1. And again, so you now have these points, again, derived from the earlier solution, and then you draw the graph, sorry. Okay, and this time you now have your y equals 2. So the region is bounded by this line, and this line. So this is the region we are referring to. So that's the triangle part. It's a triangle. So that is to be revolved over this line. And we take element that is vertical since the axis of revolution is horizontal. Okay, so the solid form will be a right circular cone, and then to be revolved over here, so you'll have an image above, and you'll generate a cone. Okay, and then yeah. So what is your R now? This is your R. Equation of this line, y equals 2. So 2 minus this line, x plus 1. So you'll have R equals 1 minus x. So that's our new R. Because we changed the axis of revolution. It's the same problem, but this time we changed the axis of revolution. So you got this volume. Okay, then again, yeah. Just take a look at on the integration process. And this time it's now pi over 3 or 1/3 pi. That's the volume. Any question, clarification? None? Okay. Okay. The next, let's try this one. Find the volume of the solid when the first quadrant region bounded by y equals x squared, y equals 4, x equals 0 is revolved about the y-axis. Okay, this is a parabola that opens up. Okay, so when y is 4 equals x squared, so you have x equals plus or minus 2. So you have 2, 4 and negative 2, 4. Okay. Okay, but we only be using the first quadrant. And this is the parabola. But we will only be using this quadrant, the first quadrant region. So this is the line y equals 4. So the region is this. Okay, and that is to be revolved over the y-axis. Okay, the axis of revolution is vertical. So ibig sabihin, to use this method, we'll be taking an element horizontal. Okay. And we have to be revolved over that line. And in this case, you can no longer use y equals x squared. Why? Because the element is horizontal. So you have to change this into x equals square root of y. Sir, why is it not plus minus the square root of y? Because we're only be using the first quadrant region. So when you take the parabola, the whole parabola, this is your x equals square root of y, and then the left portion is your x equals negative square root of y. Okay, so that's why we're only be using x equals square root of y. And this is the solid. That's it. Yeah. So how do you write your R?
R is equals to square root of y minus 0.
Okay, that's it. You have the volume. R is the square root of y and then square. All right. Then, yeah. And you have 8 pi. Okay. Then let's modify the problem again. This time, let's make use of, let me see, the x-axis to be the axis of revolution. This one. Let me see. Okay. Dagdag tayo ng slide. Just discard it. Okay, this time we'll be making use of, this is your y equals 4, the y-axis, one more. The y-axis, y equals 4, and this is the curve y equals x squared. Y equals 4, and then this is the x-axis, the line y equals 0, and then we draw an image here. So because we will be revolving it about the x-axis. So this is what will happen. Paliitin ko na lang ha. Then this is the axis of revolution. We'll have an image here. I'll make it blue to make it easier to recognize. Then yun. And then you just put an accent here. So that is the solid we are referring to. And then what happened here is when you take element that is vertical, what did you see now? is the element touching the axis of revolution?
Hindi po, sir.
Hindi po. Okay? Hindi po. It's because, yeah, the axis of revolution, y equals 0, is no longer is no longer one of the boundaries. So the question is, can we still use this method?
Hindi po, sir.
Hindi na rin po. Let's modify it again. Say, we revolve it over the line y equals 4. Yeah, so y equals 4 naman. This is the line y equals 4. One of the boundaries to be revolved over here. Oops. Then, this is the y-axis. This is the parabola y equals x squared. And then that is to be revolved over this line. So the image is above. Okay? And we generate a paraboloid. So that's it. Can we still use this method?
Pwede po ata, sir.
Pwede po. Because the axis of revolution is one of the boundaries. Okay? So how do you write your R? What is your R now?
4 minus x squared po.
4 minus x squared. Bakit hindi ko to pinalitan na x equals square root of y? Di ba kanina x equals square root of y to? Why is that happening?
Kasi po vertical element na po ang gamit.
Okay, good. Vertical element associated always with the function y equals f of x. And y equals anything in x. So we now solve for the volume. Volume is equal to pi integral of 4 minus x squared square dx. Okay, and then the limits are from the leftmost, kasi nakatayo to, from the leftmost, that's x equals 0. Then to the rightmost, what is this? X equals, if this is y equals 4, what is this point?
2 po.
2 po. 0 to 2. Then you expand. 16 minus 8x squared plus x to the 4 dx. So you'll have 16x minus 8x cubed over 3, then plus x to the 5 over 5, evaluated from 0 to 2. Did I integrated it right?
Yes po, sir.
Okay. And then we evaluate the limit. 16 times 2, 32. Minus 2 cubed is 8. Times 8, 64 over 3. Plus, this one is 32 over 5. Am I right? All right. Then you have here 3 times 32, it's 96. No? It's 96. Okay, you can use your calculator and you can help me here. That's 96 minus 64. So that's
32 po.
32. So do we have 32 over 3 plus 32 over 5. So you have 1/3 plus 1/5. 1/3 plus 1/5 equals 15. 5, 8 over 15. So you have 32 times 8 over 15. And that is 6 over 15 pi. And then you just take the lowest term if there is. Okay? So that's the new volume. Kanina, 7/3. Yun nga ba yun? 7/3 nga ba yan kanina? Sorry. Let me see again. It's 8 pi pala. Sorry. It's 8 pi. And then when we replace the axis of revolution, naging 256 over 15 pi. Okay? Ibig sabihin, the volume of the solid depends on the axis of revolution. Paglayo ng axis of revolution to the region, paglaki ng volume. Okay? Get it right? That's this method. And then just take a screenshot of this. And then what will happen, sir, if the axis of revolution is no longer touching the element or the other way around? Ibig sabihin, you can no longer use this method. So we will be using another method called the ring or the washer. If you have a ring on your hand, that's the idea of the washer method, the circular ring or the washer method. Because on the washer method, if you have seen a washer, okay, it's really typically a washer, no? 'Di ba butas yung gitna niya? Okay, ang illustration naman nun is yung polo na candy. 'Di ba yung polo ganito ang itsura, butas yung gitna. A donut, just like that. Okay, so are we done? Shall I proceed with the next method so that we can now solve this?
Yes po, sir.
The washer or the ring method. Okay, so by ring or the washer method, let's take this region. Okay, this is bounded by y equals f of x and y equals g of x. So again, we take an element perpendicular to the axis of revolution. Okay, so again, the axis of revolution is the x-axis for the meantime, and then we will just modify the equation later. And this is the region we are referring to, or the solid. Okay, so this is your radius. Okay, and then you will observe that this portion is empty, hollow. So ang illustration niyan ganito. Sorry ha. They're just like this, yung empty na yung gitna niya. Okay, so ang solid lang diyan is yung side. Okay, buo yan. Okay, solid portion. And then yung gitna is empty. So that's the idea. And last time I asked you how to solve for, say you have a circular track. So how do you find the area of the track? Yeah. This one. That is, how do you find the area of this track?
Yung area po ng bigger minus area po ng small.
And if this is the small radius and this is the capital radius, the big radius, so area ng big is pi capital R square minus pi small r square, or pi capital R square minus small r square. And we will be using this principle. And this is the small r, and this is the big R. Again, the radius, the radii, small r, big R. The radius is the distance of the element to the axis of revolution. Whereas the small r, the small radius, is the shortest distance of the element to the axis of revolution. The big R is the farthest distance of the element to the axis of revolution. Okay? This is the shortest distance, and this is the longest distance. And then, if the element taken is vertical, you can still use the y upper, y lower thing to get an expression for small r and capital R. So in this case, since the axis of revolution is the x-axis, then the y lower will always be is zero. So that's why when you take r here, so that small r, what is this? That's g of x minus this one, it's 0. Then capital R, this is your capital R, that's the equation, f of x minus the lower portion, it's 0. That's your capital R and small r if the axis of revolution is the x-axis. Now, how do we take the volume? The idea, okay, is when you take element perpendicular to the axis of revolution and that the axis of revolution and the element are not touching each other, meaning the axis of revolution is no longer part of the region, is no longer one of the boundaries. So you use the ring method, okay? And then the idea is to take a ring. Ito siya. So this is your capital R and this is your small r. And again, this is the height of the ring. Okay, so you have volume is equal to V1 running until Vn, and you have A sub 1x a sub 1, delta sub 1 of x running until a sub n of x, delta sub n of x. And then you know that the area is equal to pi times capital R square minus small r square. And then you now have this. And then you write it in summation notation. And then just the same thing when we use infinitely many rings. Okay, and then the height will become thinner and thinner and it will approach 0. Okay, and then we can now write it in limit form, and this can now be written in integral notation of this form. Integral of capital R square minus small r square dx evaluated from A to B. And this is the formula for the volume of solid of revolution by ring or the washer method. Okay. If the axis of revolution is the x-axis, then it will look like this. F of x squared minus g of x squared dx. But if not, okay, the axis of revolution is no longer the x-axis, but any line y equals x naught. So how do you measure your r? Small r. Small r, that's g of x minus x naught. What about your capital R?
F of x minus x naught.
Minus x naught. So you have this volume. Okay. Then, if it is located above, what is your small r?
X naught minus
f of x.
Okay, good. Then capital R minus
g of x.
Okay. And you have this volume. And then we go to the element horizontal, axis of revolution vertical. If this is the y-axis, then the volume, okay, is equal to this. If it is y-axis, if it's not y-axis, the line x equals 0, x equals y naught, and then you have this, and then the volume can now be written of this form. So we are now using the x right, x left thing. X right minus x left. Okay? And when it's located on the right side, this is your small r and capital R, and therefore this is your volume. Okay? Yeah, then let me see. Let me see. Balikan natin yung ating problem earlier. We will be solving this one later. Discard ko na lang. Oh, man. What happened? Oh, my. Nawala yung aking ano. Sorry. Where's that? Where's that? Oh, yeah. Ito yan. Nawala eh. Sorry. Discard ko eh. Hold on. Okay. So again, earlier we have a region. This one. Y equals 4. And this is the x-axis. Okay, and this is the axis of revolution. So this is the solid we are forming. Sorry. Okay, sorry for the bad drawing, ha. Okay, and this is the element chosen. And then you draw the distances. So make sure you have to label your graph para mas makita nyo yung element na hinahanap nyo. This is capital small r, and this one is your capital R. And then you draw. How do you write your small r? Again, the equation of this curve is y equals x squared or x equals square root of y?
Y equals x squared po.
Okay. Then how do you write your small r? Small r.
X squared minus 0 po.
Minus 0. Capital R.
Four minus 0 po.
Okay, good. 4 minus 0. From here, you trace it out. You trace it from here, then you go down. It will touch the x-axis. You start here, so it is touching y equals 4. That's why this is 4. You go down, it will touch the x-axis, and that is 0. And then you now have your volume equals pi integral from then capital R square minus small r square dx. And then evaluated from, this is vertical. So you compute the volume from the leftmost. This is x equals 0 to the rightmost, and this is x equals 2 from 0 to 2. So you have pi, 4 squared is 16, integrate 16x minus x squared is x to the 4, integrate x to the 5 over 5 from 0 to 2. So you have pi 32, that's 16 times 2, minus 32, yeah, over 5. And then the rest will become 0. Okay. And then you have half equals pi. Then factor natin yung 32 para madaling mag-add. 1 minus 1 over 5. So you have pi times 32 times 5 times 1 minus 1. 4 over 5. Am I right? Yeah? Right? Can you still hear me? Okay. So you have half 4 times 2, it's 8. 4 times 2, it's 12. So 128 pi over 5 cubic units. So that's the volume. Okay, and then ulitan ulit natin. You take a screenshot of this. I will delete my annotation. Then we will resolve this again. This time, I'll be making x equals to as our axis of revolution. Ready? Take a screenshot of this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? Okay, so we will try to redo this again. But this time, we will be making use of x equals to be the axis of revolution. This is the problem that we lived earlier. Okay. So then, this is the line y equals 4. So when you revolve this image, it will look like this. Oops, sorry. Oh, man. I'll just erase that part. Hold on. Sorry. And then to be revolved over here. So you will have an image on the right side. And sorry for the bad drawing. And it will look like this. So lagyan lang natin ng konting accent dito to make it a little, you know, solid-like. So we draw the elements. So, okay. So the axis of revolution is the line x equals 2. And then this is the line y equals 4. What element should we take? Vertical or horizontal if we want to use the washer method?
Horizontal po.
Horizontal po.
Horizontal po. Okay. So this is your small r and this is your capital R. Question. What is the equation of this curve?
X equals
X.
Okay, good. And then, what is your small r?
2 minus square root of y.
2 minus square root of y. Your capital R.
4 po.
Capital R.
Ay, 2 minus 0.
2 minus 0. Yeah. This one. This is 2. Until here, it's square root of y. Then from here, until here, it's 2 minus 0. So you have volume is equal to pi. Then capital R, 2 square minus small r, 2 minus the square root of y square dy. And then what will be the limits? This is horizontal, so you start from the bottom, 0 to the top, that's 4. Then you have pi, 0 to 4, 4, you expand this part, then you introduce the minus sign, 2 square is 4. So it will become minus 4. 2 times square root of y is 2 square root of y times 2. So that's 4. Minus, minus, plus. 4 square root of y plus, then this is minus, so minus y dy. So this will become 0, and then we integrate this part. Am I right?
Opo, sir.
Okay. So you now have pi. We now integrate this. 4 y 1 half plus 1, 3 halves. Then you take the reciprocal of this, 2/3. Multiply it to 4. That's 8 over 3. Minus y squared over 2 evaluated from 0 to 4. So you'll have pi, then 8/3 times 4 raised to 3 halves. Square root of 4, 2, cube. So that's 8. Minus 4 square, 16. Divided by 2, it's 8. Then the rest will become 0. Again, you can use your calculator to verify this computation. So we shall have now what? Equals, we factor out 8 to make it a little easier. So you'll have 8/3 minus 1. So you'll have 8 pi times 8/3 minus 1 is 5/3. So that will become 40 pi over 3. Kindly check this out. You can use your calculator.
Tama po, sir.
Tama
Okay?
po.
Okay. Then, you take a screenshot of this before I proceed with the next problem. 1, 2, 3, 4, 5. Let me see. Oh my, it's quite. Saan ba na andun yung ano, yung mabilis? Kailan nga ina? Kasi ano pa. Kailan. And ito yan, I think. Yan. Yeah, that's 45 over 3. And then another problem. We modify it again. This time, we revolve it over the, okay, I think we're done with this part na. Right? Ito yung una. Nandito din pala sila, sorry. Ito yung sinulog natin kanina. Our answer here is, yeah, 128 pi over 5. And then another problem. Okay, let me see. Hold on. One more problem. Let me see. What I'm going to do here is I will just the problem solved in area but area polar region, sorry. Yeah, okay. Area plane region, then the same problem will be given in volume, lalagyan ko lang siya ng axis of revolution. Like this one. Come on, hey. Hello. You remember this problem? Hold on. Wait. This one. Okay. So let us try to solve this by applying the hold on. Okay. To it in paint. I'll make use of the axis of revolution. I'll choose the x-axis. X-axis first. Galing ko muna to. Okay. And then snipping tool. we have this much. Okay, modify natin yung problem. And find the volume. Find the volume of the solid. The solid generated when the region bounded by is revolved about the x-axis. Now, I will not explain I will not discuss how this is traced. We all know that this y equals 3x minus x squared is a parabola that opens down and with vertex at 3 halves 9/4, then passing through the point 0, 0, 3, 0, and 2, 2. And this is a line passing through the point 0, 0, and 2, 2. Okay, so we shall revolve it over this line, the x-axis. So we shall have okay. One more. We shall have this solid to be revolved over the x-axis. Then we shall erase this part. This is no longer important. And this one. Okay. And then let me see. Hold on. Now. Rotate natin siya vertical. All right. And then Control C. I'll place it here. And we now have our solid. Right. And then again, this is the axis of revolution. We shall erase this part. And then this is the axis of revolution. And then we just put an accent. I'll use circle. I'll drag it here. And shade, oops, Control C. Oh. Y. Anyway. So this is the region. This is the solid. Okay, that's it. So then we draw the element. So you have, we take element that is vertical. Okay. Because this is easily solved when you take element vertical, right? Tama ba?
Yes po, sir.
The area can easily be solved when you take element vertical. And then we label the points. So this is your R, small, and this is your capital R. Okay. And then, how do you write your small r?
X minus 0 po.
And what about your capital R?
3x.
3x minus x squared minus 0 po.
Okay. And then you can solve your volume. It's pi, capital R, minus small r, and then dx. Evaluated from the leftmost to the rightmost, 0 to 2. Okay, yeah. Then, sorry for it, this should be square. Yeah, okay, so we have pi, 0 to 2, then 9x squared minus product of this times 2, that is 6x cubed, plus square of the second, x to the 4, right? And then minus x squared dx. So you can just combine these two. So that will become 8 pi 0 to 2, 8x squared minus 6x cubed plus x to the 4 dx. Then we now integrate. So you have 8x cubed, right? Minus 6x to the 4 over 4 plus x to the 5 over 5. Again, you help me here. Replace x by 2. So I'll have pi, 2 cube, 64.
64 po.
64 over 3 minus 2 to the 4, 16 divided by 4. It's 4 times 6, 24. Plus 32 over 5, then the rest will become 0. Alright. Paki-check ulit ako ha. Oh my, we try to factor out para mas maikli, but you can use your calculator. What is the result? Can you just give me the result? And these three are added. Thank you. How much? How many pala? Sorry.
56 over 15 po.
56. 56.
56. Apo. Over 15.
Thank you. Cubic units. Okay. The next, more. Try to modify this again. What will happen if you use if you use x equals -1? Okay, we try to do it again. This time, we use x equals -1. So, ito yung x-axis. Andito pa si x equals -1. Okay. Si y equals -1. Sorry. Y equals -1. So, y equals -1. You see it here. Now, this is almost touching each other because the axis of revolution is the x-axis. But this time, since the axis of revolution is y equals -1, and then you see that this point is quite, 1 unit away from y equals -1, then the image is also what should be 1 unit away. Okay, and done. Sorry for the bad drawing. That's it. That's the solid we are referring to. So, butas na talaga to. Butas na yan. Then, we will just set this up. Then, we will not compute for the volume. Isa-set up lang natin. Okay. So, this is your small r, and this is your capital R. Again, this is the line y equals x, and this is the line y equals 3x minus x squared. Right. So, what is your small r? X minus, so that's x plus 1. What is your capital R? 3x minus x squared minus -1. So that's 3x minus x squared plus 1. And then volume, pi, then 0 to 2, capital R, plus 1, minus square, minus x plus 1 square dx. Okay? Yeah. Sige, try natin. Solve natin. V equals pi 0 to 2. Then this is square of trinomial. For the square of trinomial, that's square of the first plus square of the second plus square of the third plus twice the product of the first and the second, twice the product of the second and the third, and twice the product of the first and the third. This is the first, second, third. So you have square of the third. Square of the first. 9x squared plus square of the second, it should be 4, plus square of the third. Then twice the product of the first and the second. This is 3x times x squared, 3x cubed, twice, minus 6x cubed. Product of the first and the third, 3x times 1 is 3x times 2, 6x. Then twice the product of the second and the third, negative x squared, negative 2x squared. Then expand this part, that's x squared plus 2x plus 1. Then you distribute the minus sign, minus, 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 dx. Then we combine similar terms before we integrate 0 to 2. Then what should be combined? 9x squared, negative 2, how much? 7, negative 1. So that should be 6x squared. Am I right?
Yes po.
Then plus x to the 4, then negative 6x cubed, and then plus 1, minus 1, this goes 0, 6x minus 2x, so that will be plus 4x. Kindly verify this expression, and then you tell me if I should go on.
Tama po, sir.
Okay, then we integrate 6x cubed over 3. 6x cubed over 3 plus, x to the 5 over 5, right? Minus 6x to the 4 over 4 plus 4x squared over 2, evaluated from 0 to 2. Then, x cubed, 2 cubed, it's 8. 6 divided by 3, it's 2. Then 2 cubed, it's 8. 2 times 8, 16. Then plus 32 over 5 minus 2 to the 4, 16 divided by 4 is 4 times 6, 24, plus 2 square, 4, 16, 8. Then the rest will become 0. Then, come on. So V equals 16 plus 8, it's 24, right? No. Then 32 over 5. Pi. Am I right?
Yes po, sir.
Okay, so that's it. As you can notice, in a specific problem, I can modify it into many problems. It depends on the axis of revolution. Okay, so that's the, that's the, I can be playful with this problem, and I can give you many problems from this. It depends on the axis of revolution. So like this one, the axis of revolution is the line y equals -1, dito x equals 0, and then I can still modify this. This time, I will make use of y-axis and x equals 2 to be the axis of revolution. Okay. Okay. Same problem, but this time, we're going to revolve it about y-axis muna. So this is the axis of revolution. This is the region, and then we're going to revolve it over the y-axis. Control C, then i-revolve ko naman to horizontal. And this is now the new solid. Oops. Okay, tanggalin ko lang to para hindi nagpapatong. Oops. Yeah, that's it. I'll just remove this part. This is no longer important. And diretso ko lang siya dito. Oops, I use black. Hold on. Then try to observe what will happen. This is the axis of revolution. And then we just make an accent here. Make it a little more solid-like. Then we shade it. Oh my. This is the region. This is the solid form. That's it. Then, now, if you want to use this method, analyze natin. The axis of revolution is vertical, so you must use an element that is horizontal, right? But if you use element horizontal, there are two subdivisions. You get it right? Hello, boys,
Yes.
girls? Okay. There are two subdivisions. Because when you do it horizontally, there are two slices. So you will now have V1, V1, V2. And then the total volume is equal to V1 plus V2. Okay? Ito yon. However, again, this problem, the area of this region can easily be solved if we use element vertical, which means hold on, one more. Control C. Which means if we take that into consideration, okay, if we take that into consideration, we shall be taking an element that is no longer perpendicular to the axis of revolution, but this time it's now parallel, right? Because this is the axis of revolution. Okay? So, ibig sabihin, taking this into consideration, the same problem, and we revolve it over the y-axis. So, we generated the solid. So, if you want to use the washer method, you take an element perpendicular. The axis of revolution is vertical line, the y-axis. So, you take element horizontal. However, when you use horizontal elements, the whole region can be divided into two slices, into two subregions. From here until here, and then until here. So this is y equals 9/4. This is y equals 2, and then this is y equals 0. So from 0 to 2, then from 2 to 9/4. And it will take, a little quite lengthy and tedious because we are solving for two volumes. However, again, when you recall the process in the area, this region, the area of this region can easily be solved if I take element that is vertical. So I'll use vertical element, okay? But when you use vertical element, the axis of revolution and the element chosen are now parallel. Ibig sabihin po, you can no longer use this method or the washer or the ring method because the axis of revolution and the element are now parallel. You get what I mean?
Yes. Opo, sir.
Okay. Okay. So that's it. Again, this method and the circular ring method is used or are used whenever you take element perpendicular. If the element is touching the axis of revolution, this method. If the element is not touching the axis of revolution, washer method. Okay. Then we go back to the PowerPoint. And this time, we will be talking of the cylindrical shell method. So one important consideration to use the cylindrical shell method is that the element and the axis of revolution are parallel. That's the only condition. So here, we will take the idea of a banana trunk. Yung saging. Diba yung saging may mga layers sa loob? Yung trunk, yung puno ng saging like this. Okay? So parang pag hinugot mo to, that's the idea. Yun. So parang ito, the smallest, pero sa loob ng smallest na to, meron pang maliit. And sa loob ng smallest na yun, meron pang maliit. You get what I mean? You can imagine that? Hello?
Apo, sir.
Okay, you can still hear me, ha? So that's the idea of the cylindrical shell method. Okay? You recall this process? Okay? Yeah. You compare the three methods so that you can easily identify, anong method ang gagamitin ko? You first draw the element. So how do you draw the element? You first consider the number of slices. You do it horizontal, you do it vertical. How many slices for each? And then you choose whichever it has the lesser number of subregion. And then after which, you compare it to the axis of revolution. Is it perpendicular? Is it parallel? If it is perpendicular, is the element touching or not? If it is touching, you use this method. If it is not touching, you use the washer method. If it is parallel, regardless whether it is touching or not, you use the shell method. Clear?
Opo.
Okay, that's it. Thank you. So this is the cylindrical method, and you look how I divide the solids into these cylinders. Okay, So again, this is the region. I used the same region earlier. Okay, bounded by the curve y equals f of x, the line L, and the two vertical line x equals a, x equals b. And we take one of the representative. Okay, so you now have the volume of the cylinder can now be computed as circumference of the base times the height times the thickness. One more, circumference of the base times the height times the thickness. And this is the circumference. That's 2 pi r. Okay, this is your r. And then the height, this much. And the thickness, that's your delta r, the change in radius. Okay, because the radius will change from one point to another. So you have here r1, r2, r3, r4. Then you know that the volume of the solids is 2 pi rh delta r, wherein delta r is the radius, and you know that delta r is change in r. And then you write it in summation notation because the volume can be written as V1, volume of the first cylinder, volume of the second cylinder until you reach the nth cylinder. And you write it this way. And then that can be written in summation notation, this Riemann sums. Okay, and then again, the idea is to use infinitely many cylinders. Why are we doing that? To get the best approximate volume, to eliminate those errors found when you divide it by series of cylinders or shells. Okay, so when you do that, you are using delta R approaching 0 when you use infinitely many cylinders or shells. Okay, and then you take the limit of it, and then now that's the integral. So that's 2 pi integral of RH dr, where r is the distance of the axis of revolution to the chosen element. And then h is y upper minus y lower. If you are using vertical, dr is dx. If you are using horizontal, h is x right minus x left, dr is dy. Let me see. Okay, ito yon. R is equal to x if the axis of revolution is the y-axis. And R is equal to y if the axis of revolution is the x-axis. Okay, then you remember this one. 2 pi rh dr. So R is the distance of the element to the axis of revolution. And r is equal to x if and only if the axis of revolution is the y-axis. And r is equal to y if the axis of revolution is the x-axis. And then h is y upper minus y lower if you are using element vertical, meaning axis of revolution, also vertical. And dr is equal to dx. H is x right minus x left if the axis of revolution is horizontal and the element is also horizontal. Horizontal element, axis of revolution also horizontal. And dr is dy. Now, the question is, sir, what will happen if the axis of revolution is no longer the y or the x axis? Okay? Let me draw you to this one. Say you have here a region. I'll take this region na lang. This is the axis of revolution. This is the element chosen. This is the y-axis. And this is the axis of revolution. You know that the distance of the axis of revolution to the element chosen is r. Okay, so that is what we're going to look for. And how far is the element to the y-axis? Any point is x unit away from the y-axis. So this is x. Say this is the line x equals c, the axis of revolution. Yeah, okay lang. Sige, x equals c. So for any constant c. Then how far is this line to the y-axis? How far? Can you hear someone?
C po.
C po. Ibig sabihin, C is equal to x plus r. Therefore, r equals c minus x. That's it. When the axis of revolution is no longer the y-axis and the axis of revolution is found on the right side of the element and the y-axis. Therefore, r equals c minus x. Okay, now we do it on the left. Say the same region, element, y-axis, and this is the axis of revolution, x equals c. From here until here is your r. How long is this? It's x. How long is this?
C po.
C po. So how do you write r? It's x plus c. Actually, it's x minus negative c because of this one. Okay, so that's it. So r equals x plus c kapag nasa kaliwa. R equals c minus x kapag nasa kanan. Paano kapag nasa pagitan? Element, axis of revolution, the line x equals c, then the y-axis. So from here, this is your r, this is your x, and how long is this?
C po ulit.
So we have x equals r plus c. So what is r? That is x minus c. Okay? You remember this expressions. Kasi it's not always r equals x and r equals y. Okay? Then let's take a problem. You take a screenshot of this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Hindi ko to masisend sa inyo kasi nadidelete yung annotation. Pag nag-move na ako ng slide, nadidelete na yung annotation. Okay. So we use the cylindrical shell method to find the volume of the solid generated when the region bounded by y equals 3x minus x squared and y equals x is revolved about the y-axis. Again, I have already presented this to you last time in finding the area. So we just recall the points. No? So this is how you trace it. Yeah. And this time, the axis of revolution is the y-axis. Okay? Actually, if you're gonna ask me, sir, saan po mas madaling mag-solve? Actually, and this is just for my opinion lang naman. No? As much as possible, if I can make use of the cylindrical shell, I use shell method. Kasi mas madali yon. Wala nang ini-square, product lang siya ng r, and then the h. And you'll understand what I'm talking about later on. Okay, this is the element chosen. Why? Because this is easily solved when we take vertical element. Then, one more. This is the region. Then you ask yourself, saan ko ba ito madaling isolve? So when I divide this horizontally, there are 2 slices. But when I divide it vertically, there's only 1. So I use vertical. Okay, you decided the element vertical. You look at the axis of revolution. It's vertical, so they are parallel. So you use the shell method. Okay, that's how easy to identify the method you're going to use. Is that clear?
Yes po, sir.
Okay, and then this is your r, the distance of the, what is r? What is the expression for r? When you see that, r is x, because the axis of revolution is the y-axis. So r is x. And this is your h. How do you write your h? Sir, it's vertical, so y upper minus y lower. So how do you write your h? It's 3x minus x squared minus x. So that's 2x minus x squared. Okay? And then, that's your dx. And this is the solid we are referring to. Okay, and then this is the formula, 2 pi r h dx. You have r is equal to x, and h is 2x minus x squared. And then you plug it there. Yeah, so you just multiply this x, each term inside. I'll not take this any longer. And then the limit is evaluated from 0 to 2, the leftmost, and then to the rightmost. Okay, and then, yeah, multiply. So you'll have 2x squared minus x cubed. Okay, and then integrate. You have this, evaluate. Then this will become 0. And then you'll have 8 pi over 3. Okay? The next, we modify this problem, I think. That's it. We revolve this over the line x equals 2. The same region, but this time it's x equals 2. Again, try 8 pi over 3 when the axis of revolution is the y-axis. And let's see if the axis of revolution is the line x equals 2. What will happen? Okay, then we draw the solid. And then we draw the elements. That's your h. Okay, how do you write your h? It is still y upper minus y lower. Then how about your r? What about your r? That's your dx. What about your r? The axis of revolution is still located on the right side of the y-axis and the element. Okay, that is your r. This is x, and this is 2. So what is your r? 2 equals x plus r. Therefore, r equals 2 minus x. Okay? You get it right? Hello?
Yes po.
Any question, clarification, if there is? None? Shall I proceed?
Wala naman po.
Okay. So we have this volume again. I'll not focus on the integration. You just multiply this 2 by FOIL method. So this is 4x, negative 2x squared, negative 2x squared, then positive x cubed. Integrate, then evaluate, and you'll have 8 pi over 3. Okay. Let's see. One more. There's none. I'll just stop recording. Oh, wow.